Okay, class, let's get a little practice with these ideas of inverse sine, inverse cosine, and inverse tangent functions. Okay, so I've got this annotated over here for the inverse sine function. The domain goes between -1 and 1, and it's inclusive. So we're going to bracket the -1 and the 1 because they are also part of the domain, as is the -π/2 and the π/2 part of the range. Now, so this green space is where we're looking for sine. And remember that we don't use the normal indicator for the angle. We have positive angles and negative angles. So I've marked those up as well here. And we know that it goes from -π/2 to π/2. The tangent uses the same space with one detail difference here. Notice that I've got parentheses around the -π/2 to π/2 because they are not part of the range. They just indicate where it begins and ends. And then the domain is all real numbers. All right, so let's take a look at this. And we want the exact value. Whenever they ask for the exact value, they basically mean it's going to be coming from the wheel here, and we'll be able to read it from special angles. So let's take a sine. They want the inverse sine of 1. Okay, so we're looking for where y is 1. And we're finding the angle. So we could say 90 degrees if we're working with degrees, but we're going to work with radians today. So we're going to say π/2. Find the exact value of the inverse sine of -1/2. Okay, my negative y's are down here. So I'm looking for this one, and I don't use 11π/6. I use -π/6. So the sine inverse, -1/2, results in the angle -π/6. Okay, now if they ask for approximate values, then we can see we don't have an option here. There is not a coordinate on the unit wheel for y that matches 1/3. So we're going to have to find that. We're going to use a calculator. So let me bring the calculator out. And we can see that on our calculator, the inverse sine is right above the sine. So if I want to ask for the inverse sine, then I'm going to say second function, and it says give me the inverse sine, and then I want to put in 1/3 because that's what it was asking for. So 1 / 3. And that means I can approximate it to 0.3398 if I use 4 places. So we can say that the sine inverse of 1/3 is roughly equal to 0.33, what'd I say? 98, yeah. Okay, so the sine inverse of -1/4. Go back to our calculator. Get our negative. Okay, it's roughly -0.2527 if I round 4 places. Okay, now let's do a few involving cosine and tangent, their inverse functions. So this first question in the next group is going to ask for the exact value. So that means we're going to use the unit circle of find an angle whose cosine is 0 is basically what this is saying. Okay, so I'm looking for in my domain and range an x value of 0. And that's going to happen right here. So in radians, it's π/2. What's the exact value of cosine inverse of -√2/2? Okay, so remember the cosine reaches on this top half of the unit circle, and we're looking for an x of -√2/2. That happens right here, and our angle is 3 pi over 4. Now we're going to go back and find the exact values. So where is the, oh, I'm sorry. So now we're on inverse tangent, and we're going to find the exact values. So tangent inverse of 1. And remember, that's going to be, has to be in this realm here on the right half of the circle, like we have for the tangent. So I'm looking for number over itself, which happens right here at pi over 4. And that's a positive 1. Down here, it would be a negative 1. So that's going to be equal to pi over 4. Tangent inverse, negative square root of 3. Okay, so remember we have to divide y by x to find a tangent. So we're looking for a y divide x that's going to be exactly negative square root of 3. So the other last video, we took a look at square root of 3 over 2 divided by 1/2, and that simplifies to square root of 3. So we're going to be taking the negative square root of 3 over 2 divided by 1/2. So that's going to actually simplify to negative square root of 3. So if I divide this by this, I can see that I'm at negative pi over 3. Okay, now let's take a look at when we have composite functions involving the sine and the inverse sine. So if we have the sine of x on the inside, then it gives us the result of a sine, and then the inverse sine gives us the angle for that sine. So in this case, we need the x to be an angle between negative pi over 2 and pi over 2, because that will give us something for the y value that's within the domain and range of the sine. So look at this first example that we want the sine, inverse sine of the sine of pi over 8. And I can do this so long as pi over 8 is between negative pi over 2 and pi over 2. And so since it is, this rule is going to hold, and I can just say, well, that has to be pi over 8. Okay, this part B is a little bit different. We're asking for, on the inside, the sine of 5 pi over 8 doesn't fall within negative pi over 2 and pi over 2. So think about 5 pi over 8. So pi over 2 would be the same thing as 4 pi over 8. Okay, so if I go one more to get to like a 5 pi over 8, and it's somewhere over here, that's going to be an xy pair. And if I think about the sine, it involves y. So to get back into the portion of the circle that we can use, this has an equivalent y. So this maybe is the opposite of x. And then this is x and the same y. Okay, so y is going to be the same in these two locations, and this is 1 pi over 8 beyond 4 pi over 8. So this would be 1 pi over 8 before the 4 pi over 8. So we know that this is going to be 3 pi over 8. This is 5 pi over 8. Right, a little bit harder to see that, but that's a 3 pi over 8, and we know that it's got the same y coordinate as a 5 pi over 8, and it is within our bounds here for the sine. So now we can say that the sine inverse of the sine of 5 pi over 8 is equal to the sine inverse of the sine of 3 pi over 8. So we moved it to into our bounds, and now we can use the rule, and it's just going to pop out as 3 pi over 8. All right, so example 7 was pertaining to this 4a part here. This was for example 7. For example 8, we're looking at this one here. So if I take the sine of the inverse sine of 0.5, I just need to make sure that this x value is between -1 and 1, and it is 0.5. So I know that the result is going to be equal to 0.5. Now, on the other hand, when I come to this one, sine inverse is on the inside, and I need x to be between -1 and 1, and it's not. So we don't have any remedy for this. This is just undefined. Okay, so it worked up here because we could capture another angle that's in the region allowed for the sine that had the same result for the sine. So we just moved it into a friendly space for the inverse, and then we're able to find that 3 pi over 8 is the result. Okay, let's look at some analogous properties for the cosine. So if I take the inverse cosine of the cosine of x, it's equal to x, but I need for the angle to be between 0 and pi. And then the cosine of the inverse of a cosine is equal to x, so long as x is between -1 and 1. Okay, so let's look at this first situation, the cosine inverse of the cosine of pi over 12. So we're up in this 5a territory. And since pi over 12 is greater than or equal to 0 and less than or equal to pi, not much work here. We just bring that out and say, okay, pi over 12. Everything is okay there. So let's move to this part B. Now we're in the other 5b territory because our inverse is on the inside of the composite function. So I need for this value here to be between -1 and 1. And since -0.4 is between -1 and 1, I get to bring that out and it pops right out. It's -0.4. Okay, so here, when we get to part C, we've got a situation where -2 pi over 3 is not between 0 and pi. Remember, we got this, that's the orange part that we're wanting. Okay, so we do have something that we can use here. Remember the rule that said a cosine of -theta is an even function, so it's equal to the cosine of theta. Okay. Okay, so for part C, we're just going to rewrite it as the cosine, the inverse cosine of the cosine of 2 pi over 3. And we can make it fit into its domain. And we get 2 pi over 3. Okay, so for part D here, pi is about 3.14. If we only want 2 decimal places of accuracy, but we know that 3.14 is exceeding the 1. It's not between -1 and 1. So I can't fit it into the inside function in the first place. So there's no way to get something out of it to take the outside function. So this is going to be undefined. Okay. Okay, let's look at this example involving tangent. So if I take the inverse tangent of a tangent of x, it's going to pop out as x so long as x is between -pi over 2 and pi over 2. So for this first example here, we're going to have to adjust this a little bit to make that happen. So the tangent, the 4 pi over 5 angle is going to be somewhere around. So this would be 1 pi over 5, and then 2 pi over 5, 3, and 4 pi over 5 is going to fall somewhere around here. So that's going to be some negative x. and then a y. And if we look for that, this would be 5 pi over phi. So this distance from here to here is just 1 of the pi over 5. So that makes that 4 pi over 5. Okay, so across here on the other side, if I go a little bit over here, I'm going to have the same absolute value for x and y, but it's going to be a positive x and a negative y. So it's going to generate the same tangent, but it's going to be in a quadrant that's accepted by our tangent. So we can rewrite this as the tangent inverse of the tangent of 4 pi over 5 is equal to the tangent inverse of a tangent. And so this is negative pi over 5. Right, we had to go back by pi over 5 to get here, so we have to go down by pi over 5, negative pi over 5 to get here. So now that we found the angle that's in the range and domain, and it has the same tangent as the one that we were given, this will pop out as, hey, that would be negative pi over 5. All right, so that's this situation here. This one, it works all the time, no matter. So if the inverse tangent's on the inside, because its domain is all real numbers, and then the domain for the tangent is also all real numbers, that's always going to work. This one, like we did for that other example, we might have to rebuild it into the portion of the unit circle where its inverse tangent is defined.